Hi everyone, my name is Walter Quadrini, and here I'm showcasing some experiments or some evaluation about how we made AI contribute to the circular economy of printed circuit boards. So you may know that the electronic waste in Europe is kind of a serious issue because these items are very difficult to dismantle, and through the mass production of electronic devices, they are growing day by day. As a mitigation action, there is a circular economy. So we had a lot of redesigns because of the semiconductor crisis, but the circular economy is supposed to also to contribute to reduce it. So basically, devices or components that can be reused or recycled are disposed separately. The thing is that disassembly PCB components is quite hard because these objects are small, because there is a huge variety on PCB form factors. So this makes very difficult to detect and to remove the components. Therefore, it's a matter of humans. So humans are deployed to do this. And to do it, we worked on some automotive derived PCBs. So in this case, you can see some dashboards from cars. And we had the issue of the low volume of data because there are not a lot of data sets about PCBs and not a lot of data sets about the defected components of PCBs. So which of them you can retrieve and which of them you have to dismantle. So we had two choices, focusing on synthetic data generation to increase the data volume, or adapting some model architectures to increase the performance with low volume datasets. So for what concerns the synthetic data, we have relied on several data augmentation techniques in order to generate more and more samples of normal components, of defected ones, from different classes. Then the typical application, we deployed YOLO model to detect the components, and you can see in this slide we are detecting the integrated components on this PCB, which are numbered in the GUI on the right. The synthetic data generation, we induced different types of defects, so soldered pins or burnt components. And we did it for both the integrated components and for the capacitors. And then we made a transfer learning on YOLO V5 in order to train it to detect these components, and we further increased this with another dataset that was open source, and we retrieved. It worked. See you in the next clips.